Today, we're zoning in on two really interesting bits of tech in the SUI ecosystem. We've got Walrus, which is doing some clever stuff with decentralized storage, and DeepBook, which is tackling decentralized liquidity in a new way.
Exactly. And we've got some good material to work from the official Walrus docs, a really insightful article explaining SUI through DeepBook and the specific white paper on the DeepBook token itself.
Okay.
So the plan really is to pull out the core ideas, the main mechanics, how they might connect, and why you, listening, might find this useful in this whole crypto space.
All right, let's do it. Let's unpack Walrus first. Reading the docs, it's clear it's not just like another Dropbox alternative. What's the core idea? I mean, how do dApps handle huge data without AWS or Google Cloud?
Right, that's the fundamental problem Walrus tackles. At its heart, it's built for storing and getting back large binary objects, big files, videos, that kind of heavy data decentrally.
Oh, okay.
But it's more than just storage. It gives you a cryptographic way to prove that the data is actually there and that it's available when needed.
And the thing that jumped out at me was the cost efficiency. They talk about this advanced erasure coding. They call it red stuff.
Yeah, red stuff.
Getting about a 4.5x replication factor. Why is that number actually important for, someone using this?
Okay, so that's where it gets really clever. If you just make tons of full copies, the docs mention needing like 25x replication for 12 nines availability in some systems.
Wow, 25 times the data.
Yeah, it gets incredibly expensive super fast. But just storing one or two copies is obviously risky, right? If a node goes down.
You lose the data.
Exactly. Walrus, with red stuff, hits a kind of sweet spot. This erasure coding gives you really strong protection against nodes failing, but with much less storage overhead, around 4.5 times the original data size. So think about it. For similar safety, you might be paying way more with simpler methods. Walrus is much more efficient with the storage space.
So red stuff, it's not just like hitting copy-paste multiple times. How does it actually work? What's the magic?
It's pretty neat. It uses a two-dimensional erasure coding scheme.
Yeah.
So imagine your data laid out in a grid.
Oh, okay.
Encoded across the rows and down the columns. The benefit is if you lose a piece of data, say a block in that grid goes offline.
Yeah.
You only need to download a relatively small amount of the other data proportional to what was lost from the remaining rows and columns to rebuild it.
Ah, okay. Not the whole massive file again.
Exactly. Unlike older systems where losing a chunk might mean downloading the entire thing. Plus, the docs mention it supports asynchronous network challenges.
What does that mean, asynchronous challenges?
It's a security thing. It basically prevents a dishonest node from just pretending it's storing the data. The system can challenge it to prove storage, even if the network connection isn't perfect or immediate, making it much harder to cheat.
Got it. Smart. Okay, so it stores data efficiently, proves it's there. How does SUI, the blockchain, fit into this picture?
Right, the SUI integration is key. Walrus uses SUI for all the important stuff, coordination between the storage nodes, verifying the data is available, handling payments securely. They even model storage space itself as a native SUI resource. So you can actually own storage capacity, transfer it.
Like an NFT for storage space, kind of?
Sort of, yeah. And the data blobs themselves. Also SUI objects. This means SUI smart contracts can directly check if your data is available on Walrus, maybe pay to extend the storage time, or trigger deletion.
Wow, okay.
And because SUI is built for speed and low fees, all this coordination and payment stuff happens pretty efficiently.
That sounds really flexible. What about the people actually, running the storage nodes? How's that managed?
Good question. Walrus uses a committee of storage nodes. And this group isn't static. It changes between epochs, which are just set time periods on the network. And this is where the WAL token comes in. There's also Frost, which is just a smaller unit of WAL, like cents to a dollar, for easier small payments.
Okay, WAL and Frost.
Yeah. People can delegate their WAL tokens, basically stake them, to support specific storage nodes they trust.
Giving them their vote of confidence.
Exactly. Nodes that attract a lot of stake get selected for the committee for that epoch. WAL is also what you use to pay for the actual storage service.
And the nodes get paid.
Yep. At the end of each epoch, rewards are distributed to the nodes doing the work and the people who staked with them. And it's all handled automatically by SUI smart contracts, so it's transparent.
Okay, so there's a clear economic incentive and governance layer. The docs also stress it's resilient, even against nodes that might be offline or, worse, malicious. How do they pull that off?
It's really that combination. You've got the red stuff error correction, which can rebuild lost data.
Right.
And you've got the fact that the committee of nodes keeps changing. Plus, they use standard Byzantine fault tolerance principles designed in the system so it keeps working even if some participants are faulty or dishonest.
Okay.
And having SUI smart contracts manage the node selection, the proofs, the payments, that adds another layer of security and automated trust.
Right. Okay. So summing up Walrus, sounds like cost-effective, robust, decentralized storage. It cleverly handles node failures, integrates tightly with SUI for trust and management, and has this efficient red stuff recovery. Pretty compelling.
Definitely.
Okay, let's switch lanes now to DeepBook. The article positions it as like a core piece of SUI's whole vision for this interconnected super application world. What's DeepBook actually for? You know, DeFi liquidity is always a challenge, right? Finding buyers and sellers.
Yeah, absolutely. DeepBook's main goal is to be a unified liquidity layer protocol built right onto SUI. Think of it as creating this big shared pool of funds that lots of different DeFi apps on SUI can easily tap into.
A central liquidity hub.
Kind of, yeah. The article really links this to SUI's idea of frictionless interaction between smart contracts. DeepBook is meant to provide the essential fuel, the liquidity, to make that vision work.
And SUI's speed helps here?
Massively. The article points out that SUI's fast transaction finality is crucial for something like DeepBook, especially its order book structure, to actually work well in real time.
The article also hits on this DeFi liquidity challenge. It mentions liquidity mining, just printing tokens to attract funds isn't really sustainable, right? How is DeepBook different for the average DeFi user?
That's a really important point they make, just constantly inflating a token supply to bribe liquidity. It often just devalues the token for everyone in the long run.
Right, you see that a lot.
DeepBook's approach is different. It aims to provide deep liquidity at the infrastructure level. So applications building on SUI can plug into this existing pool instead of having to bootstrap their own liquidity entirely through potentially damaging token incentives. It helps the whole ecosystem, too, by stopping liquidity from getting fragmented across dozens of small, isolated pools.
So it provides this core liquidity. Now, mechanically, the article says it uses a central limit order book, a CLOB. That sounds more like, you know, the stock market than typical DeFi AMMs. How's that different?
That's a really key distinction. Unlike many automated market makers, or AMMs, where prices are set by an algorithm in a pool.
Yeah, where you just swap at the current rate.
Exactly. DeepBook uses a CLOB. This means you, as a trader, can place limit orders saying, I want to buy X amount at this specific price or better. Or sell orders, same idea.
So more control, like on Binance or Coinbase.
Precisely. It's a more familiar model for many traders and can be much more capital efficient for certain strategies than just swapping against a curve.
Okay. The article then talks about pools in DeepBook and mentions some big upgrades coming in V3. What are these pools and what's changing for users? Like, how is the order book actually set up on-chain?
So think of a pool as the dedicated trading floor for one specific pair, like SUI and USDC.
Got it.
Each pool holds the order book for that pair, processes the trades when orders match, and handles the assets. Now, V3 refines this structure internally. They're splitting it into three parts. The book itself for orders, the state for tracking history and status, and the vault, which handles the actual asset movements securely when trades settle.
Making it more modular, sounds like.
Yeah, more efficient, more robust.
And V3 also introduces a pool registry and a balance manager. What do they do?
The pool registry is like the master list of all official trading pairs on DeepBook. It stops duplicates, keeps things organized.
Prevents confusion.
Exactly.
Yeah.
And crucially, it also manages different versions of the core DeepBook exchange code. This ensures consistency and stops liquidity getting stuck on older, incompatible versions.
Okay, makes sense. And the balance manager.
That's a central shared object holding all the user asset balances within DeepBook. It manages the funds, makes sure orders are funded using things called trade proofs.
Trade proofs? Like a receipt?
Sort of, yeah. It's like a cryptographic guarantee that you actually have the funds available to back the order you're placing. It helps make the settlement process smooth and secure.
So if I actually make a trade on DeepBook, walk me through what happens behind the scenes.
Okay, so first, an order info object gets created with all your trade details. If it's a market order, just buy or sell at the best current price, it tries to match immediately.
Right.
If it's a limit order, it checks the book for matches at your price or better. If there's a match, a fill object is created, logging the trade details.
Okay.
Then the order book gets updated. Maybe your order is fully filled and removed, or maybe just partially filled, and the remainder stays on the book. The pool state records the transaction, and finally, the assets actually move between accounts via the vault.
Seems logical.
And V3 is aiming for lower transaction costs overall. Plus, adding user-friendly options like an AMM-style swap interface for simple trades, and even things like flash loans for complex strategies.
Flash loans, too. Interesting. Now, the DEEP token, we mentioned the white paper. What's its role, and what do V3 upgrades mean for people holding it?
So, DP is DeepBook's governance token. V3 really beefs up its utility. First, you can use it to pay trading fees,
Okay, utility for fees.
but also you can stake Deep. Stakers can get discounts on those trading fees and potentially earn maker rebates, basically, getting paid a little for providing liquidity by placing orders on the book.
Ah, incentivizing liquidity providers.
Exactly. And staking also gives you governance rights, so you get a say in how DeepBook evolves.
The white paper goes deep on the fees. It sounds pretty dynamic, designed to reward activity and liquidity.
It is. Taker fees, what you pay for taking liquidity off the book, fluctuates based on trading volume in that epoch, maybe between 10 and 5 basis points, even lower for stable pairs.
So busier market, maybe slightly lower fees.
Potentially, yeah. And maker incentives rewarding those who add orders to the book also adjust dynamically based on how much liquidity depth there is. The idea is to encourage liquidity where it's most needed. For wash trading faking volume, the system is designed so fees collected always exceed incentives paid out and any excess is burned. This makes wash trading inherently unprofitable.
Okay, removes the incentive.
Yep. And for governance attacks, there are built-in limits on how much parameters like fees can be changed in a single vote, preventing extreme swings. Plus, that nonlinear voting power also acts as a defense against capture.
Right. And lastly on the token, the distribution plan. Seems focused on the long term.
Absolutely. Out of 10 billion total Deep, only 10% is for initial community airdrops, about 28% for core team and early backers.
Yeah.
But the vast majority, over 61%, is earmarked for future grants, community programs, ecosystem growth.
So heavily weighted towards building things out.
Definitely signals a long-term vision.
And it's pretty impressive. DeepBook V2 apparently did over $5 billion in volume in its first year on Sui. V3 sounds like it could really boost that.
Yeah, the anticipation is high.
The article even argues DeepBook helps show why a fast, monolithic chain like Sui has an edge in DeFi. Can you expand on that? Why is DeepBook important for Sui's overall story?
The core argument is this. Because DeepBook provides this efficient shared liquidity layer right at the base level. DeFi projects building on Sui don't have to spend all their energy in token emissions just desperately trying to attract liquidity themselves.
They can focus on their actual product.
Exactly. They can focus on building cool, innovative features, knowing that the fundamental liquidity is already there, accessible via DeepBook. It fosters more composability, potentially more sustainable tokenomics across the board, and lets Sui's speed really shine for complex financial applications.
Okay, that makes a lot of sense. So we've looked at Walrus for storage, DeepBook for liquidity. How do these two pieces fit together? Do they interact, or are they just separate infrastructure on Sui? How does this help me as a user?
Well, while they solve different problems, they're both fundamental building blocks for the Sui ecosystem. And yeah, you can definitely see potential synergies.
Like what?
For example, Walrus could be the perfect place to decentrally store all the historical trade data from DeepBook. Or maybe store governance proposals related to DeepBook securely and verifiably.
Okay, DeepBook uses Walrus for data.
Potentially, yeah. And going the other way, DeepBook could easily become the main place to trade the WAL token used by Walrus, or even trade those Sui objects representing storage capacity we talked about earlier.
Ah, trading storage futures almost. So, wrapping up, Walrus seems like a really smart take on decentralized, storage-efficient, resilient, integrated. DeepBook looks like a sophisticated liquidity layer moving beyond simple AMMs, and both are deeply tied into Sui's architecture.
That's a good summary.
What were the most sort of innovative bits that struck you from each?
For Walrus, definitely that red stuff erasure coding. The efficiency and the way it handles recovery and challenges is pretty advanced.
Yeah.
For DeepBook, I'd say the dynamic fee model trying to balance takers and makers, plus that nonlinear governance to fight centralization. And just the ambition of being that foundational liquidity layer is innovative in itself.
It really does make you wonder. With these kinds of powerful tools for storage and liquidity becoming available, what kinds of new decentralized applications suddenly become practical? Things we maybe couldn't build before on other chains.
Exactly. It opens up possibilities.
It's definitely something to think about. And hey, if you, the listener, found this interesting and want to go deeper, we absolutely recommend checking out the sources. For Walrus, look for their dev blog, the usage guides, the sites info, the design docs, and the glossary. For DeepBook, Grab the main docs, the tokenomics paper, and anything labeled DeepBook on SUI.
Loads of detail in there.
For sure.
Yeah.
Well, thanks for taking this deep dive with us today.